Perfect. Okay. So, are you developers or are you related to operations? Dev. Also. Yeah, okay. Well, me too. I'm also dev. So, a few words about me first. Well, as I said, I'm a developer, and I always position myself like a developer. But in the last few years, I've been involved a lot with the operations guys, and I was helping them to automate stuff, and not actually also I was doing their job. At some point, I'm working in a small consulting company, and we mostly work in Scandinavia. And you can find my connection details on that slide that we publish later. So if you need to know to connect me later, just use this information. So what this presentation is about? Well, it's basically our take on DevOps, how we started on that, how we implemented that, and what was the tooling, what was the reasoning behind the tools that we chosen for infrastructure provisioning, for continuous integration, and continuous delivery. A technology that I'm going to touch in the second part of this presentation are Groovy, Gradle, Jenkins, Puppet, and AWS. Are you guys familiar with any of those? Like, is there any like Java developer, Groovy developer here? Okay, cool. So this part is Java. Do you guys use Jenkins? Any of you? No. Bamboo. Okay. Anyone using Puppet already? No, nobody. Do you use Chef or Ansible or?
No, we just use Puppet internally in DevOps.
Okay. AWS, Amazon? Everybody, I guess? No, not everybody. Well, it's just this presentation will show a showcase, a use case of how we glue this all technologies together to introduce kind of DevOps environment inside a couple of our clients. So. Have you guys heard the term DevOps, I guess, before? There are like a lot of opposite opinions about what it is and how it is defined, and actually there's no official definition of what DevOps is, and there's no manifesto like with Agile or like with reactive programming. There's no manifesto of DevOps. It's a term that was introduced by Patrick Dubois. Well, he is called the father of DevOps. But since then, nobody, and actually it's an intent to not define a manifesto for DevOps, because it's not because the DevOps guys, they were kind of afraid of following the path of Agile, where you have or basically created the church of Agile, and everybody was looking at the manifesto and trying to implement it, and took it by very literally in that sense. So DevOps doesn't have a manifesto. And in order to introduce what DevOps actually is, I'm going to tell you the story. And this story is not a real one. It's a made-up story, but it's based on the patterns that I've seen in a couple of our clients. So imagine you have a traditional organization which is broke up into departments. Or silos, which live in their happy world and maybe talk to each other quite rarely or do not communicate that well. Well, it depends on organization, but imagine that we have this department boundaries between people who do development, people who do testing, people who do operations, and maybe management. So at one point, the manager decides that we need to make a new project, a secret project that, and we need to set up like 10 development servers for that. So it's easy. We did it before. So he just sends an email to system administrator called Jack and asks him to set up those servers. No problem. Let's get to work. We know how to do it. We order the hardware. We start setting up networking. Everything is done with first server, second one, and 5 days later we are pretty much done with everything. So, and at this point we get some kind of miscommunication probably that people want to start working on those servers quickly. And since the work is already done, it's no problem. Then Jack is kind of saying, it's okay, we're done. At the same time, Jack has his own boss in his own department, and his boss asks him to actually provide documentation according to department's guidelines and document everything. And Jack says, no problem. We do it. We know how to do it. We have guidelines. We have checklists. We write documentation, and everything is perfect. So he handovers this stuff to developers. At the same time, developers are actually starting to use those environments. They realize that something is not really configured as they want, because development is going forward, and they need a new component, and they need a new setting on that environment. So they send a CR, change request, to Jack through the manager. And Jack kind of started to implement that because and because he does that because he's also busy with something else. At some point he started doing that, but then he didn't finish that, and then eventually dev servers are not usable. So he got a complaint from developers who are actually using those servers, because they're using that on a daily basis, and at, let's say, 3 a.m. At night, Jack is saying, okay, it's done, it's working, you can use them now again. But things get worse, because you get more change requests coming from different departments, different managers saying that we need this, we need that, and they're not really coordinated, and eventually Jack is just overwhelmed with the amount of work he gets. So, and the thing is that the servers are kind of up. They're working. They have some applications deployed to that. They actually are monitored in some way. But the problem is that it's worse than down, because the state of those servers actually is unknown, because Jack is not controlling his work. He's driven by priorities that are given to him by his managers, and those priorities are usually not in a good order, or not organized at all. So what you get eventually is that servers are in the state that nobody knows. Nobody can reproduce that state. And at that point, documentation, of course, becomes obsolete and outdated and unusable. So what you get is kind of chaotic. While it was in development, it was kind of okay, because it was only for developers, and developers also put their hands on those servers, fixing some stuff for Jack. But secret project that was in development for a while needs to get into testing, and that's why they need a new environment for testing that stuff. But things are getting really worse at that stage, because now change requests for running configurations are coming also from testing guys who need this and that for their database setup, and sometimes they even produce some kind of change request about information they don't even understand. And Jack is basically overwhelmed with all that, and because he needs to manage all those environments and keep the pipeline working, and the more you get working on those environments, the more unique each one of them gets. And at that point, already the documentation is thrown away. Nobody even considers looking at that, and eventually you have to go live. You have to deliver the project, and you have to show that you have to start earning money on the project. And the more environments you get, the worse situation becomes. And the usual approach to solving these kind of problems is that let's throw more people at that. Let's ask Jack's colleagues to help him with setting up the environments and fixing stuff. But the problem is that it doesn't really help a lot. And eventually, the whole operations team working only on production. And there's random fires appearing here and there, and all other environments stay absolutely in even a worse state than production. So everybody cares only about production, and nobody cares about other environments. So after some hard work and long nights, those guys make the production work. Project starts generating some money, but still problems appear here and there, and management asks, do we have monitoring? Can we see that something is bad with the environment? And operations guys say, yes, we do. We actually do have a lot of those. We I don't know, use some kind of Nagios or some other monitoring tool that shows us the state of the environment. The problem is that the monitoring is really basic. It's not bound, it's not connected to what application actually does. And the state that you can actually get is that the dashboard is green, but the obvious problem, that application doesn't work, is not visible on that dashboard. So basically, the worst thing you can have in operations world is that a customer calls your manager before you actually notice that there is a problem. Ideally, operations guy should actually notice that before any kind of calls. So the only thing that operations guy can say at this point that sorry, we work hard, we work all night, we work overtime a lot, we'll go on weekends, but sorry, we can't handle it. We did just too much information that we are not given, too much pressure is on us, and we can't do anything. So is there any kind of happy ending to that story? Well, first of all, let's see where the problem is. Obviously that developers and operations guys, it's lack of communication between them. And in an organization where these two departments are separated by the boundaries, usually the communication happens through the management, not through the people who actually do stuff. And of course, information is kind of lost or not propagated thoroughly. Another issue that happens here is that when operations start caring about the production, they kind of lock it in. It's ours. It's our job to support it. So they don't give the information back to developers about what's wrong, about what can be improved like in the application deployment procedure and application structure, so that it's easier to operate. And this information is locked in production. It's not given back to developers, so they can actually do something about it. And what developers do, they just fix obvious bugs, and they don't fix operational bugs, which are fixed manually by operations guys in production. Another issue with this kind of when things are separated by departments and the communication between departments is not happening well, is that most of the developers, they are well organized. They can actually they follow agile principles. They do a lot of changes to the code. They do testing. They do. On the other side, the operations department is even more separated than developers. Developers are more or less working together, but operations they separate even further. So it could be guys who are responsible for networking, guys who are responsible for servers, setting up servers, guys who are responsible for monitoring, and those guys can even be isolated from themselves, from each other as well. So. And this kind of leads to a situation when people really, well, like on this picture, these are two different countries, and when they try to talk to each other, it's more like different Ministry of Foreign Affairs talking to each other rather than people talking to each other. And another thing is that which is natural for developers versus operations, is that. Developers like changing stuff. They like adding new code, new features, and then move on. On the other hand, operations like stability. They don't want the change to happen often. Then they want the system to run. And if it changes often, then it's a threat to a stable system. So basically, operations and developers have opposite goals. On the other hand, the main goal of DevOps is to actually, with agility, also bring stability to the process. So, of course, if the system is hard to deploy, then operations guys will try to postpone the time when how often and when the application is deployed to production, because if deployment is fragile, then each deployment causes problems, and each deployment may mean that the system is down for a few days or maybe even weeks. And it's really unpredictable process if it's not automated. And obviously, if there's a fear of deploy, then management and system operations and also developers try to make this cycle of deployment longer. And this of course is against any kind of things like continuous delivery or continuous deployment, because if you can deploy often, then you can change often, and then the agility goal is basically not achieved. And of course, in the long run, it influences the whole organization. And so this DevOps thing is really about not only about devs and ops working together, but actually the whole business working together in order to in order to achieve the business goals. Because if operations guys, and operations means not only system operations, but also it could be like accounting or guys who are doing marketing, for example, and then like or guys who are doing software development or business development. If those guys are not really talking together, working together, then the business goals will be not met, because they are try to isolate that in a silo. And eventually, well, if the business cannot effectively achieve what it needs, then obviously nobody is happy. If we look at what are the main issues when this miscommunication is happening, and when things are not automated and in the right way, is the unplanned work. Basically, unplanned work can kill any kind of organization. And if you see on this graph that if the change rate is pretty much code change rate, the change rate to the environments is pretty much staying on the same level, but the number of failed or changes that are not that are done in a wrong way, like manually or not in the way it was documented, then the amount of unplanned work can eventually become bigger than the amount of time you have to do any kind of work. So, and if it is, then you're basically doomed to the organization is doomed to die. On the other hand, if there's another parameter that can influence the amount of unplanned work, is the number of unique configurations that you have in your organization. And that means that, for example, if you use 2 different or 3 different application servers to deploy your code, if you use several operating systems to deploy your code, I don't mean only Windows and Linux, but for example, if you use different Linux distributions to deploy your code, that's already something that maybe is not worth doing. If you have different versions of libraries or 2 different branches of your code that is maintained and separated and maintained and deployed by different teams, that means that the number of unique configurations that you have in your organization is big. And if this number is growing with time, then obviously this leads to a situation that the mastery that you can that you have over each of those configurations is going down. So if you have many configurations, you can't be good at all of them. You will be somewhat okay with all of them. And then if it's bigger, then the mastery obviously is going down. And if the mastery is going down, then the success, the change success rate is going down as well. And this obviously also influences the unplanned work, which can again become at some point the reason that organizations just stopped and not doing anything except unplanned stuff. And well, as already mentioned, DevOps is something that is supposed to solve these problems. So, obvious thing is that you have to play the same game. With developers and operations have to play the same game and maybe talk directly to each other. And another important point, that the feedback loop should be closed. So it's not only developers saying we need to deploy this to production, but it's also operations guys saying, okay, we deployed it to production, but we have this and this problem, and we changed this and this. Please apply it to development as well, so that the information flow is actually a loop, and people can minimize the number of changes, actually minimize the number of unique configurations, because I often see that like development environment and production environment actually are completely different beasts. And if they are, then of course we have different people to master them differently. But if you can minimize the differences, then obviously it's easier to support it, it's easier to maintain, and easier to facilitate the automation. So, so the feedback loop, like feedback is always important, and that's why in Agile and Lean and other methodologies, it's important to get feedback often. The same thing is applicable towards operations. So if you can get feedback from operations guys who actually deploy stuff to production, and you can apply it to development, then obviously that improves the whole situation, and then that improves the ability of organization to react quickly to changes. And if the feedback loop gets shorter, then obviously you have more time to focus on some other stuff. So another important aspect of DevOps is that you're actually sharing responsibility, not only for the code, but for the whole process. So people actually work together to introduce automation and introduce knowledge sharing between all departments. And this not necessarily includes only these three, but also others maybe. So, and then it's important that everybody work together, so that the deployment of application, the delivery of application code, the delivery of changes in the configuration is done effectively, and of course eventually it actually reduces the risk of changes. So you remove the fear of deployment. And obviously, if you remember recall the first graphs, that if the number of failed or unauthorized changes goes down, then obviously also your operations guys and your developers have more time to focus on real work rather than on unplanned work. And obviously unplanned work goes down. The same happens with unique configurations, that if you have fewer unique configurations that you use in your organization, then obviously the mastery of each configuration that you have to support is growing. And obviously the change success rate is growing as well, and this obviously also reduces the unplanned work. Okay, great. We've heard about DevOps. That's cool thing. Let's do it. It will probably save the organizations. But as with any methodology, as with any approach that people take to make life better, there are some failed expectations. And the thing is that DevOps, most of the people, they start with the tools. But tools are as important as internal culture. It's like with Agile, it's like with Lean. If you don't make the whole organization work in that direction, if you don't make people actually care about that, about automation, about sharing the code, about sharing the knowledge, then just using the tools may not give you the expected result. And there is a nice acronym that I think also defines DevOps very well. It's called CAMS. It's about culture, automation, measurement, and sharing. So obviously, if people should care about what's happening with the whole life cycle of the code delivery and the application and business in general. And to make the feedback loop shorter and easier to follow, automation is an essential part of DevOps. So you can't do DevOps without enough automation. Another part is that the measuring of what's happening with the process, like introducing continuous integration, dashboards of good monitoring of your application is important part of giving visibility to what's happening to everybody. and of course, sharing. So the whole thing, the automation part, in form of like scripts or form of code, and measurements in form of dashboards or monitoring tools should be shared between people, and it should be visible to the whole team that is involved in application delivery. In that way, it kind of gives a good feeling to everybody, and everybody knows where we are, what's happening, and stuff like that. Well, if we get back to what we did in that area, we started with the tools as well. We started with the tools because we were developers, we still are developers, and it was easier for us because we like coding, we like writing code, and we started with the tools that we had at that point. So there's another term, probably you've heard that as well, called infrastructure as code, and we wanted to go in that direction to automate huge application deployment based on Java that we had at that point. It was like almost 5 years ago. So we wanted that to be built from source control. We want to utilize tools, the existing tools that we had in place, or maybe some good tools that are there on the market, and we also wanted to ensure testability. So this was our dream, and that we actually what we eventually implemented. That everything that could be in version control is in version control, and the only way things are getting onto the environments is through automation procedures. So we try to avoid manual changes as much as we can, and this actually goes hand in hand with the chart that I showed you with the unauthorized changes, which produce unplanned work. So if things are automated, then nobody needs to do it manually. And yeah, that's just another picture. So if we talk about Java deployments, that imagine that you change a class file and repackage a jar and put it directly in production server manually. If you have a need to do some merging code, some merging code change. No, nobody does it like that, obviously, because it's against it's against common sense. Even though I know some people do that in very urgent situation, but usually this deployment of new code happens through automatic deployment. So, and developers do that automatically. They have scripts to do that automatically. And the thing is that so should be also the infrastructure configuration changes. So everything that is related to application, including the additional components that application needs to run, additional like logging settings, monitoring settings, which come hand in hand with the application, they should be also be propagated in the same way. And the fewer manual changes you allow, the better situation will be eventually for everybody. Also, if you keep all the stuff in version control, this also allows you, especially if you talk about infrastructure management, like everything that surrounds application, then if you at some point you need to change the architecture of your application, or if you need to extend the architecture of what's going into production, then if that thing is in version control, then and if it's exposed as infrastructure as code, then it's much easier to react to architectural changes as well. And just this is an example for a typical Java application. Let's say you have a Tomcat server, and you develop your GSPs, and you talk to your database. So it's easy to set up this stuff on your laptop, and it's easy to say operations, hey, do the same on production, and you can just write a document. And it's very easy. On the other hand, when your application is growing and you want to split the layers and you want to deploy them to different roles, to different servers, then you have to somehow separate the deployment, like deployment of the database changes and deployment of application changes. And maybe like when you were at this point, your deployment scripts that you had, they were relying on the fact that everything running on the same machine. And it worked fine before you switch them and before you split the layers. So you have to adjust that again. Then at some point you decided that you have too much logic running in your application, so you want to split that, and you want to put a load balancer, so you have some kind of failover as well. Again, this changes the way you deploy. So, and if it works fine for developers, it still is quite different for those guys who actually deploy the code. Then again, to facilitate failover even more, you would like to introduce additional server for additional MySQL database slave that will handle additional load and to do failover if needed. Then at some point you realize that your application is needs some caching in front of that, and then maybe also some of the background jobs were initially running on the same machine where the web application is taking too much time, so you want to get it to another server. And eventually, of course, you have to think about security and monitoring, and this all is considered usually part of what operations people do. But in fact, that's what developers should also care about, and that's what they can care about, and that's where what both developers and operations guys can work together on and put it on the same version control. I'll try to show it later a bit. So, what if our architecture, our initial architecture was different? So we used different framework like Spring Boot, for example. It would, or even it would be some kind of Grails and let's say MongoDB. It will have the same problems. At some point we decided to split, then we wanted to scale, then we wanted to security monitor and caching. This all kind of, they seems to be the same, like the same layers of stuff. And I often find that people think that it's kind of similar for all applications, but it's not. Actually, it's quite application specific. And like with the example of monitoring dashboard that I've shown in my story, that when you ask people from operations, I need monitoring of this application. What they do, they monitor memory, disk, and CPU. But my application is much more than that. And memory, disk, and CPU may be good, but application may not work well because there's not enough monitoring information about what's happening in that. So monitoring, security, caching, load balancing is quite specific to the application itself, and it goes with as application develops, and it should, I think, should be kept together, so that and it should allow as well to different topologies. And one more issue that happens with when we have this traditional waterfall development of application where we don't care about operations early enough, is that development starts at some point here, then we go to QA where we test stuff, but because the operational problems were not thought of before early enough, when system goes to production or pre-production or in any of those states, operations guys either are not aware of how to deploy the application, how to make it work, or simply the production setup is so different from what you do in development that you just don't, you didn't face the issues that you should have faced if the differences between production and development environments were minimized. And that's what, and of course, number of issues when you go to new topology of deployment, it's obviously growing. And so basically what I usually see in many enterprise setups which use this pipeline development with dev, QA, and maybe some other levels of environments, is that development is somewhat but very much different from QA environment, and production environment is very much different from what you actually have in a development environment. Of course, the ideal way would be that they are different, but they are just different based on their scale, not on their setup, not on their configuration. Slightly better way would be that even those environments actually are very, very similar. And if you're going to something like continuous delivery, then usually it may even mean that your development environment is your production environment. which happens in very extreme cases. But if you can achieve that with the automation level that you implement, then why not? So what was our path inside a big Java project that we had? So of course we understood that automation is the key, and we needed to support eventually around 100 servers, different environments, and production was like 12 servers out of those. We are JVM hackers, so it was a Java project, and we had a lot of Java programmers on board, and we wanted to reuse that knowledge inside the team, and also to apply our knowledge to what we did. And the problem at that point was also that a lot of things were fragmented, not only inside the applications we had, but also in DevOps automation world in general. So our initial tool set included these tools. We were at that point, like almost 7 years ago, we used Gradle as a build tool, and we used Groovy as a scripting language and well, Gradle is based on Groovy. We had some unscripts, we had some Python scripts, we had some VLST script, which is WebLogic scripting language. We were using WebLogic, and we had a bunch of shell scripts, and all used for different stuff, written by different people, and all combined together in quite weird ways. So what we needed to support deployment and infrastructure provisioning at the same time, that we needed infrastructure connectivity, we needed the tools that can allow us to provision the environments, create new environments, and keep them up to date. We also wanted to look into a bit of virtualization of environments, and we wanted also to verify that what we do with our provisioning tools is actually testable. So the first blood that we had is that since we already used Gradle, and Ant is like a tool is another build tool that is probably the first build tool for Java, and it exists for like a lot of time, for a long time, and it already had a connectivity task like a SSH exec and SCP task for connecting to remote SSH hosts, and we just tried to use that. And Gradle has great integration with Ant, so it was just easy to reuse the task definitions from Ant. So our commands, our remote commands for managing environments, from doing some tiny deployment task into a tiny infrastructure management task, each one of them was pretty much looking like that. So we were repeating stuff like host, username, password, whatever. Since Gradle is actually based on Groovy and you can write programming, you can write functions in that and methods, we just created a helper method around that, which looked eventually like that, and also for copying files. And what we kind of came up with initially is like a closure that runs around all the servers that we want to configure, and then inside that we can run SSH tasks. Still, there was a bit of repetition, and the problem was that with the complex tasks, it was actually looking like that. So it didn't become much more readable. And the more complex it became, the more things we were trying to manage, the more ugly this stuff became. Another issue with that implementation was that Ant was making a new connection each time. It was we were explicitly repeating this props parameter all the time, and the scripts were hard to maintain, especially the more complex they become. And the other issue that we found very unpleasant to work with is that most of the tasks that we defined, that we automated, they were not idempotent. So you can run them once, but if you run them the second time or the third time, then you get a failure, or you get some weird state. So it didn't really help to support the state of the environments in that sense. And of course you can expand, because it's programming language and you have full ifs and loops and everything. If you can expand your task to have ifs there, like say, if this is installed, then don't do this, or do something else. Then, but this only increased the complexity of the scripts and tasks that we had. So we realized that we needed something new for that, and we actually created a DSL for working with SSH remote commands. This improves some stuff, and we also implemented some features on top of that. So we could do that remote command execution. We could do file uploading, downloading. We can do also tunneling, which was important for us to do SSH tunneling for the environment setup that we had, because some of them were behind firewall. Why did we do it in Groovy? Why did we write Groovy in first place? First of all, because we already used Gradle, and Gradle build scripts are Groovy, and Groovy is based. It was inspired by Ruby, and as you know, Ruby is good for DSLs, and Groovy is probably even better for DSLs. And it's already more than 10 years old and very mature, and it has very concise syntax. And yeah, we actually wrote a book about it, so was no other way. We only can use Groovy now. Yes, here it is. So just, and Sugar was just, it can be used together with Gradle or it can be used separately. So the easiest way to use Sugar is like, first you have to import that, and then because Groovy has a built-in dependency management mechanism, you just say that I want to fetch this from a remote repository and put it into make available to my current script. So everything is like, you can write one script and everything like dependency management, and the actual script will be in the same place. Then you can define like things, normal things like users and key file that you want, or password that you want to use, different login options. And then you can group your commands inside a closure, and in this way we avoided repetition of the parameters. So basically executing command, then also we introduce a couple of abstractions inside the DSL that we can treat some remote things as in a similar way we would treat for example, there's an abstraction for remote file which you can apply, like you can set the full content of the file for a text property. So yeah, also since Groovy supported multi-line, you can also do that in the multi-line way. Also the same for SCP. So it's a very simple DSL for copying files from like, and you can interchange like local directory, remote directory, local files. You can make many of them. So it was very easy again to, and then compared to what Ant had, it was the size of the scripts reduced a lot. And of course you can also do some logic for the results that, for example, commands return, and was not possible with Ant because it was a bit more complicated with passing Ant stuff back and forth. So, for example, in this case, it was getting the result of the command, and then checking the status of the remote command, and then based on the output of that command, it throws an exception, for example. So it was very, very good for us, and we actually reduced the size of the scripts, and it was the next step that we achieved in automation. Also, we introduced a few shortcuts that you can, like, if OK, basically executes the command, and if it returns something that is, if it returns 0, then you basically get true, and the same fail. If it returns non-zero, then you get inside that block. Also, the tunneling part was quite important for us, as I mentioned, and thanks to the nature of Groovy and the functional paradigm that Groovy implements and the closure that it has, we can actually write the whole code blocks inside tunneling stuff. So basically here, the tunnel method opens a tunnel on port 8080 and gives the random local port to us, and then we can just go to the local host on that local port like it is locally, but actually it's a tunnel to the remote machine. And then we can implement some logic. In this case, we're just flushing the cache for a remote machine. Yeah, also some other things that we introduced in Sugar, like prefixing and suffixing. It was very good to like work with sudo commands if you work with Linux, and basically each command will be prefixed or suffixed with the text that is specified in the block, and you can combine them as well. So it was a good step for us to minimize and to the size of the scripts and to work a bit more towards the readability of the scripts. But still, the complex ones were still hard to maintain, and still people were not really paying attention to making the scripts idempotent, and that was one of the issues that we had to struggle. So at that point, we realized that writing SSH scripts and things that integrate over SSH and manage huge and complex environments is probably something that somebody else already did, and at that point we came to Puppet. Why Puppet? It's because now we had there are several tools that are competing between each other, and which one is better, and it'll probably a lot of flaming will come if people start arguing about which tool is better. At that point, we thought that Puppet was more mature than competition. It still have, I think, the largest community of all the tools. The other tools I can mention, like Puppet, Chef, Ansible, Salt, are probably the four most popular ones, and I think Puppet still kind of wins the battle in that sense. The main selling point for us, because we had a development team, we had operations team, and the main selling point for us was the readable DSL. And when we showed the DSL to our operations guys, they were saying, "Oh, okay, I know what it means. I can use it," and it was kind of a gluing point for us if we don't force them to program Groovy, or we don't force them to write sugar scripts, but we actually give them something that they can understand and they can read, and then something that is in their domain, because Puppet is a DSL for defining the state of the servers. So. And developers kind of like it as well, so it was a win-win situation in our case. Because unfortunately most of the tools that are written for operations, they are either written in Ruby or written in Python. And we had no much knowledge of Ruby in the team. Also the guys in operations team, they were more like Bash lovers. So having something that is first of all simple and readable, on the other hand it's not a programming language really, was a very good selling point for everybody. So just an example of how you can manage infrastructure with Puppet. There's a simple Puppet manifest that defines that I want to install this package, and I want this file to exist with these permissions, and before I do something with this file, I actually require that the package is installed, and if there are some changes to this file, I want that the service SSH is notified, and we also ensure that the service actually is running. So even though this is like a plain file, plain text file, this really, it defines a graph. And graph with relationships between resources, and the thing is that this script is idempotent. So if you run it once, it will work. If you run it twice, it will work. If you run it 10 times, it will still work. And the way it basically works that if you have a new server, to start using Puppet, you need to install it on that server, and you need to install the minimal application system. Well, it's a nice term in DevOps communities called JOS, so just enough operating system. So you have a base image where you put on the server. Then you have like networking and all the connectivity part that you can connect to that server. And from that point, you can already start using Puppet. So you can put your manifest into version control, and those manifests can define the state of the server that you want, like packages, services, users, files, cron jobs, anything. Application deployment servers, whatever. And the thing is that Puppet manifest it's not an executable script, it's a manifest. That's why it's called manifest. It declares the state of the server you want the server to be in. So if you have starting with state A and manifest declares the state to be like that, then Puppet will turn it to be that. If it was already in state B and you apply the manifest, then nothing will be changed. If some troll has changed the state manually and Puppet manifest is applied again, the state will be restored. So in that sense, Puppet is not only like an installation tool, not only a provisioning tool, but it also can be used as an auditing tool. So you can actually verify that the state of the server that you are maintaining is still the same as is declared to be. And of course, can compare it to the scripts, custom-made SSH scripts or bash scripts or sugar scripts. This is a huge step forward because it's much easier to write a declarative manifest, and it will be understandable by more people, and the state will be managed in a completely different way. Also, another good part of Puppet is that you can actually package your configuration as a module, and in that sense, you can leverage reuse of configuring the same stuff for the same servers. So, and then the module is basically a collection of manifest, collection of templates, and maybe also, if you choose to, you can also write Ruby extensions inside that. And installing a module is pretty much similar to using any kind of resources like file or service. You just say, I want this module to be included on this configuration, and then that's going to be applied. Puppet has already a lot of modules. I think it's more than 3,000 in Puppet Forge, the registry for Puppet modules, and it has different stuff for supporting databases, security, networking, and then messaging and other stuff. So it's a very vibrant and active community. And also there are many modules in Puppet Forge, but also there are many modules on GitHub, and you can always pretty much find module for anything that is popular and used very often. Also, Puppet actually supports Windows, but maybe to less extent than Linux. But the thing is, the Puppet Labs are committed to support Windows even more. So they actually do a lot of special Windows-based modules and Windows-based resources. So if you have a heterogeneous environment where you have Linux and or Unixes and Windows, you can still manage them together. Maybe still in a different way, but still have maybe the same tool set chain that does that. As I already mentioned, that developers usually try to automate deployments. Infrastructure management is not always automated, but it could come together. And with Puppet, you have two models of deploying the infrastructure changes, the manifests, to the actual servers. And there is one that is promoted by Puppet Labs themselves. The Puppet Master is basically the central server where all the manifests are stored, and every server in your server farm actually running the Puppet agent and talks to Puppet Master from time to time. And then when the new changes are coming into the Puppet Master, it forces Puppet agent to apply the changes. The thing is that this is the good model, but it's probably not really applicable in a situation when you need to deploy changes often. Both application and infrastructure changes. It maybe works okay if you are purely a hosting company, for example, which only does operations. But if you're a development and operations company, then it's maybe worth going more for the push mechanism, where there's no agents or masters in the network, but when you just push stuff on the remote node, and when you run the Puppet command manually. So that's the model we selected also for our deployment. So also combining application deployment and infrastructure change deployment together. So first we apply the infrastructure changes, then we deploy the application through normal stuff like copying the var file or jam to the remote machine. So we combined the things that we had, like Sugar, Gradle, and Puppet together, and created this push mechanism as a way to deploy. The this is like basic stuff that we did with the automating the stuff in Gradle. So we packaging the Puppet configuration, copying it to remote machine, unzipping it to a location where Puppet will find it, and then we run the Puppet apply task that will actually apply the needed configuration to the node. So what we solved is that we still used Sugar and Bash together and Gradle to implement some kind of operational tasks that that were needed to maintain the system, like for example flushing the cache. But at the same time, the infrastructure state management were separated into Puppet manifest, Puppet modules. So we can, and then because those two actually have a bit different life cycles and a bit different execution models, we managed to separate them at this point. So we used Puppet for infrastructure state description, and we used Sugar and Bash scripts for managing, maintaining the system when it was needed. And also the scripts became more maintainable and also idempotent at that point. Especially when you have the Puppet manifest describing the state, it's idempotent by definition. In the meanwhile, we also starting to get other clients with, and we started also developing ourselves some modules for Puppet. They were more generic than the actual application required. And we needed some kind of testing for them because we wanted to deploy some of those modules to different platforms, different operating systems. So we needed a way to test those modules. So how do we test that? And because we're Java developers and we kind of, the de facto approach to write unit tests and any kind of tests in Java is using JUnit. So, and we wanted to keep things simple. So we wrote a simple utility called punit. Puppet unit was at that point. What punit actually basically is it's basically a combination of Sugar and JUnit, and we kind of already, but because we were using JUnit, we were using reporting features of JUnit, and like we could write our tests of the infrastructure provisioning in Java. That was, or in Groovy. That was our one of the main goals. And it could be like look as simple as that. So yeah, we're running some remote command, and then we're doing some search with checking that the file contains something, and that. Of course, we had more complex tests, but essentially it's a unit testing framework which allows you to test something that is in a certain state, and it was working pretty well for us. So we could test different Puppet modules and the state that they apply to the environment after they applied. Okay, there's some. So, and we also put all that stuff obviously together into continuous integration framework, and in that case it was Jenkins. So, Sugar, Gradle, Puppet, punit, Jenkins were combined together to actually provide testability for a configuration module. And yeah, that's basically like we had a Derby module. The Puppet Derby module was installing Derby on a remote machine. Derby is a database, Java-based database, and we could run unit test against the final installation. So we were using Puppet to install and provision environment with Derby, and then unit was. And with the help of Sugar, was testing that the state of the provisioning is the one that it wanted to be. So next problem is that yes, we tried to reuse the infrastructure that we had at that point with testing and everything, but obviously we wanted that to apply this to as many operating systems as we could, and to give it to as many clients as we could. So we wanted to test it in different operating systems. We want to run the tests in parallel and in multiple architectures, like maybe testing that the module works on Red Hat 5 and Red Hat 6, and maybe also on Ubuntu. And of course, we didn't want to set up a lot of service for that. And of course, we turned to Amazon Web Services, which is probably the de facto and standard now. And we use Elastic Compute Cloud to start new instances and start new servers for provision testing. Also, at that point, we Amazon has a great API of their own, but we wanted to integrate everything into the same stack, so we created a simple library to actually do the same thing, like starting of the machines and stopping of the machines from Groovy. So we wrote a simple library called Gramazon. It's just a Groovy-based API on top of the API that Amazon provides. They actually have a Java client for that. And we integrated with Gradle. So we had like Gradle tasks to start a new instance and terminate an instance. So basically the flow that we had was that when we wanted to test Puppet module, we start a new instance in Amazon, we upload the module, the manifests, we run our tests, we generate the report, and then we terminate the instance. And this whole flow was defined as a Jenkins job, as a CI job. And the thing is that if the job fails, let's say it's running the tests, it will not terminate the instance. So we can actually go on the instance and check what's wrong and see the reports, see which tests have failed. And of course, at some point, if we didn't follow how many instances are still running, a lot of them were running. So we had another script that actually was terminating instances that were running for like 5 hours. And that was the flow that we had for testing Puppet modules. So next issue, we realized that running some of the modules, some of the modules actually got quite complex at some point. For example, we created a WebLogic module for Puppet to provision WebLogic instances. And that module, actually to install WebLogic on an Amazon instance and to grab all the files and start the whole setup, it takes a lot of time. So we realized that we probably need to speed that up by having some base images with some certain stuff of already pre-installed. So, for example, WebLogic already uploaded to the server and maybe already installed, and then we can test, let's say, the WebLogic domain creation and stuff like that. So we, again, because we could and because we wanted to integrate everything with Groovy and Gradle, we created a simple tool for creating base images on Amazon. And the thing is that this tool is inspired by another tool called Packer. And at this point, we're not supporting Imagery anymore. We also switched to Packer. The problem with Packer at that point was that Packer didn't support Puppet provisioners, but we needed that, so we actually wrote a simple tool for that. But now Packer is pretty great for that. So you can create images for Amazon, for Vagrant, for other stuff, and you can use the same script basically to define base images with pre-installed stuff for use with for use in your environments. Yeah, that's a simple configuration example. So, just to summarize things. During our journey to the DevOps and during like testing of provisioning code, we realized that the operations work and is actually separated through these 3 different areas. First of all is the support of the base operating system images, and there's actually an anti-pattern in DevOps community called the golden image. So if you put a lot of stuff on your golden image, then obviously it's very hard to maintain that, especially if you have already environments started from your golden image and you want to make changes to that, then changing those environments is pretty much impossible. So that's why it's of course important to have base images, and like tools like Packer can help in creating those. But this image, the base operating system images should be as minimal as possible, and you have as few of them as possible as well, because it's very hard to propagate changes through operating system image. But the tools are needed. The next step is actually defining the state of the infrastructure that you want to apply, and as you can guess, for that part, we use Puppet manifests to provision and to install components, to ensure that the services are running, the packages are installed, users are configured, and stuff like that. We use that. For certain tasks, Puppet may be quite slow, and Puppet may not be the tool to use for let's say frequent deployments, or for tasks that, for example, for flushing of the cache. It may not be useful to use Puppet to flush the cache because it's the task that it needs to be executed maybe not that often, and it's more like a reaction to some event rather than part of the deployment pipeline. So, and as you see, those things are actually crossing each other. So there is no like rule of that this one goes here, this one that goes there. It really depends on the organization that you have, and some of those things actually can be defined in several areas. So, for example, you can have the base image having some basic some initial versions of the library, but then you can use manifests to provision to change that based on the base image, and this may allow to support like the small amount of base images. And also, so some of the things can be done through manifests, through this infrastructure provisioning, state management, and some of the tasks, like for example, Puppet is like defined for managing a single server node, so it's not really good at orchestrating cluster deployments. In that case, I think the later part is like when you implement your clusterization or orchestration of cluster deployment in a different way, or like on top of Puppet or on top of Gradle, then it's probably like it's a better way of doing that. Just to show the big picture of what we had in our first project is that we, basing on Gradle, Puppet, and Jenkins, and using the small libraries that we created, we could connect to our environments, so it was environment connectivity. We could actually create the environments in the cloud. We could provision them with Puppet, and we can test them with JUnit and PUnit. Okay, conclusions that we dragged from our experience. First of all, we tried to reuse our existing knowledge, and in that case was Java knowledge. And it actually helped a lot to gain support from the team, because if we would try to implement that using some Ruby libraries or Python libraries, that would probably be more disconnected than it eventually became. It actually was a quite good connection between all developers and operations eventually. And yeah, we needed to build a bridge between devs and ops. So we needed to have some trade-offs and agreements, and allowing Java developers to reuse the tools that they used, and giving operations and developers single DSL for communicating, like Puppet DSL was a good choice for us. We also managed to reuse some of the practice from testing of provisioning code for operations part. So it was really infrastructure as code. It's not only like you write scripts, but you also test scripts, and you can get the reports out of those scripts. Yeah, we actually tried to use new technologies, and that's probably nobody should be afraid of trying that, because unfortunately none of the ecosystem that currently exists, like Java, C#, Python, Ruby, they provide a full stack of things that actually work. So it's really about mixing them together and working together with the different groups in the organization, because usually operations they may like Bash, or may like PowerShell, but they don't know a lot about like Python, or I don't know, Java or Groovy. And another interesting thing that we actually found, that infrastructure configuration or software configuration is actually outsourceable, because we actually developed a few Puppet modules that we gave to our clients for the products that we didn't write. So like, for example, we had like some modules for configuring Jenkins and Nexus, and configuring Nginx and Apache, and we could create an isolated Puppet module for that, test the module on at least 3 operating systems that were needed at that point, and we could give those models just to operations guys, and they applied it to the service, and it worked, because it was a code, and it was tested, and it was just working. So configuration is actually sourceable. So you don't need more people to manage configuration. You can actually ask someone to write a good tested module for you. And automation is definitely important. So some books that you can probably read in the regard of DevOps and AWS and Groovy. Well, the first book is the Phoenix Project. Have you heard of that? No. Well, actually, this book is it's not a technical book. Well, it is technical in a way, but it's actually a fictional book. It's it's a story about a guy who was managing an operations department in the big corporation. It's a made-up story, but it's very interesting to read, and it's very easy to read. And also, it's written by a guy who's doing a lot at the moment in DevOps community. So he's also organizing the DevOps conference in the United States. So it's worth following the guy as well. And he's also the author of the pictures of this unplanned work graphs that I showed you before. So the Phoenix Project, well, yeah, just try to grab it. It's really easy to read, and I actually read it in 2 evenings, and it was very nice. Of course, you probably heard of this book, Continuous Delivery, and usually continuous delivery in DevOps, they like pretty much mean the same thing, and kind of similar thing. And well, you can't really implement continuous delivery without making your operations guys to automate everything and work together. So DevOps, continuous delivery, they usually come together. Another good book about releasing and deploying and is released from Michael Nygert, Danish guy. Also, there's several books about Amazon EC2, but this one is okay to get introduction into the APIs and everything. So, because well, at this point in time, with all the APIs that we have, starting in a new environment is really like a few lines of code, and it really it's really easy. I mean, it's no excuse to do it manually. You can automate all the whole stack. Yes, if you are into Java and Gradle, and definitely read this book, or there are actually other books about Gradle. It's a great build system, and the good thing for us was that we could actually combine the build system that we use for building our applications, and together with we use the same tool to actually deploy applications and provision infrastructure. So it was a win for us because we used knowledge. We combined the functionality together. Of course, if you want to know more about Groovy, you can read this book, and technologies to follow that in terms of that. Vagrant. Do you guys use Vagrant? Anyone? No? Well, actually try it. It's really cool. Well, the good thing about Vagrant is that it's basically a wrapper around different virtualization software, and I usually use it with VirtualBox. So I can start locally an environment of operating system that I want, or actually operating system that is of the same version that is running in production. And I can provision it with the same scripts I provision the production environment or QA environment or development environment. So Vagrant is a very handy tool to actually create local virtual environments on your laptop. And given that the power of laptops is actually growing, so for example, this machine has like 16 gigabytes and 4 cores, I can start pretty heavy servers, and actually even simulate like production topology, like starting 2 or 3 or 5 servers within this laptop and provisioning them with in the same way I would do that in production, and orchestrate them in the same way I would do it in production. So Vagrant is very handy in that, and it's very easy to use. It's just a single file, like single Vagrant file, which is very similar to a build file, and where you define which servers you want, what kind of networking you want with them, what kind of base image you use for them, and then that's basically it. And then Vagrant sets up all the connectivity locally. And you can actually use Vagrant also to like configure private network inside your laptop. So I use it in that mode all the time now. So I configure my Vagrant machines with some real APIs which are only visible from my laptop, and then I can provision them like using the same tools as I said, just kind of connecting remotely, but it all happens locally. So it's very handy. Docker is another trending technology. You probably heard about that. It's another way of looking at provisioning as well. It's mostly Linux based. Microsoft does support that to some extent, and they announced that they're going to extend support to that even more. But if you're working in some kind of legacy environments which do not run on Linux, but let's say run on Solaris or some old flavor of Red Hat, or then Docker is not really usable. So if you have a chance to, like, you have a greenfield project and you don't have any legacy, then Docker is definitely a way to try to go to at least see what is good for. But if you have a huge legacy of environments, and if you have Windows environments as well, then Docker basically doesn't work there. And it's also possible to combine Docker and Puppet together if you need that. Well, Packer, I already mentioned that tool, is a tool for creating base images. Camo is another virtualization software that you can try to use together with JClouds. It's more for Java developers. It's a Java library for working with different cloud providers, and they abstract the cloud provider and different services that they have. So this library could be a basis for automation of if you don't use Amazon but you use some other cloud provider, then you can use the JClouds as a basis, because they have a lot of they already integrate with many providers, and you can probably just reuse the code that they created for your automation procedures. And CloudBees is the company behind Jenkins. Okay, one more thing. All the tools that I mentioned, like Sugar, Gramazon, they all are libraries and they all open source, and they all are findable on GitHub. Also, together with Sugar, we actually created the similar DSL for managing for remote connection over WinRM for Windows machines. So, because we at some point for one of our clients we needed to combine this automation tasks. One were using SSH, another one were using WinRM, and we needed to combine them together. So we created a similar DSL for connectivity. PUnit, Gramazon, Imager, they all are available. So take a look, play with them, contribute. Would be nice. Okay, any questions? The good thing, for example, about Gradle is that it supports the packaging of any kind of artifacts. So we also applied the same logic we usually apply to the libraries in Java. We actually package the Puppet configuration, Puppet module, we version it, and we deploy it to main repository, which is like default way to deploy in Java. And then we can, upon provisioning, we fetch the right version from the artifact repository, and we apply it to the environment. So the patching is done by applying different version, and Puppet will see that, okay, there's a new stuff I need to install, and we'll install it. But if something is already installed, it will not touch it. And that's why the Puppet manifests are really good in describing the state. If something is appended to that, it will just apply only that part. Even though there's a small gotcha with Puppet manifests, is that if something is removed from that, from Puppet manifest, then it doesn't mean that Puppet will remove that like service or package. It basically means that Puppet will stop managing that package. So if you need to remove some stuff from environment, like remove some package, remove some file, you have to explicitly say, I want this file to be absent or this package to be absent. So it's not really like seeing that something is removed from manifest, just means that it doesn't manage that anymore. So this is like one gotcha with the Puppet. Oh, actually, it's pretty much with any kind of environment provisioning that you may have. Like if you just write a SSH task, and you suddenly remove part of that, it will just not do that. And that is the same with like Ansible and Chef and everything. So, if you really need to maintain clean environments, then probably it's worth actually sometimes, or maybe on a regular basis, to recreate the environments. So your provisioning scripts actually set up a completely new and fresh environment, but also try to run the same scripts on the old environment to see that it actually didn't break anything. And and because we had like a chain of environments like DevWeek, and so we actually could see that if we apply the Puppet module to a dev environment and suddenly it breaks, then obviously something is wrong with the module. So we can change it and then apply it again and then test it in QA, and then probably there will be okay. So it's kind of the same principle as with the code.
Could you give us some more information on Docker? It's maybe about we should talk about Docker.
Well, I don't use Docker myself a lot.
Is it mainly for listening?
Well, Docker is kind of is an alternative to virtualization, I would say, or it can also be implemented on top of virtualization. Basically, Docker is a way to make a container out of your configuration, and you can also define what you want to be inside the Docker image using a Docker file. It's like a simple build file with simple format, and you can kind of chain these containers on top of each other. So it's kind of a mix of virtualization and provisioning together. And I couldn't really so far play with that too much, so I can't give you like expert advice on that. But yeah, it's trending a lot, so it's everybody talks about that, and the thing is that it's still a developing project, and still a lot of things are going inside, and they actually changing the APIs and changing the tooling that they have, also introducing Microsoft support. So I think it's not yet totally ready for like industrial support in production system, unless you are like ready for problems, and unless you are really into that. So if it's really like, if you have what you have like a lot of legacy environments and like a traditional enterprise setup, then Docker is maybe it's too early to be used in these kind of setups. But definitely worth playing. Definitely worth it's probably a future. Well, you probably should look at all of them to build your own opinion, because at this point this field is evolving a lot. Like and also Docker and Puppet, they don't exclude each other. You can use them together, in fact. And at this point, many of the tutorials that are available in Docker, they're very simplistic. Puppet can actually and you also in Docker you depend on images existing somewhere on Docker Hub, so you can download them and use them. Puppet is a bit more reproducible in that sense. You can just grab the scripts and apply it to anything, to any server to which you can connect and install Puppet and run Puppet apply. In Docker is a bit more involved in that sense, but yeah, you can combine those tools and try to play, and it really depends on what kind of environment you have. Because at this point, Docker is only supported by Linux and by certain kernels of Linux, so you can't really use it for every kind of Linux. And Windows support is going to be introduced soon, to some extent. So.
So do you see Puppet as a parallel technology for Docker?
No, I'm not using Docker, so. So I'm playing with Docker, but I'm not using it for client setups at this point. Because unfortunately it happens to be that I mostly work with enterprises, with who are lagging a bit behind the technology, and Puppet is great because I was able to run Puppet on Windows, on Solaris, on IX, and it works. It works and it works fine. Running just installing Docker on Solaris, for example, is impossible. No, actually, it's quite related, I would say, because as soon as you automate the provisioning part of your environment, so you can easily recreate those by applying creating a plain new server. Let's say if you use virtualization, if you use AWS cloud, You can just create a new server, and you can provision that with the same scripts. You just provisioned the server that died, for example. And this is kind of disaster recovery that can happen, because you don't depend on the state of the server anymore. You don't treat your, well, there was actually a saying in DevOps community, like, treat your servers as cattle, not as pet. Because basically you can kill the cow in the horde any time, because it will not make the horde better or worse. But if it's a pet, if you love it, if you do like care about that, of course you're afraid of losing that. But if provisioning is automated, of course, if you lose the server, it's a bad thing. But if you make backups, if your configuration is provisioned, and if you define everything as code, then you can easily recreate that environment. You don't care about okay, we'll lose it. Yeah, it's a problem, but we will.
How long did that the whole provision of that life cycle from no server to completed server? How long did that take?
Well, it depends on what you want to put in that server. But yeah, usually it's like less than half an hour to like create a new machine with like completely from scratch. And if someone needs a new environment, like for testing something, we can just run a script to create server in AWS and AWS, provision that, and then that's it. Use it, and then deploy the code, and then like. Any other questions? Well, thank you.